But we'll start this morning with our second keynote after the wonderful Asa Briggs lecture yesterday, our second keynote of the conference. And I am personally delighted to welcome Professor Timothy Drysdale from the University of Edinburgh. He's going to speak to us about the inside story of changing minds about digital education in university practical work. And I'm particularly delighted to welcome Tim because we were former colleagues at the University of Edinburgh, where he infected me with his enthusiasm and passion for engineering education. And I started to see the immense potential in his work with remote laboratories, which you're going to see this morning. Professor Drysdale holds the chair of Technology-Enhanced Science Education in the School of Engineering, where he's also the director of Strategic Digital Education. His discipline background is in electronics and electromagnetics, completing his undergraduate and doctoral engineering degrees at the University of Canterbury in his home country of New Zealand. Prior to joining Edinburgh in 2018, he was a senior lecturer in engineering at the UK Open University and the founding director and lead developer of the Open Engineering Laboratory, a £3 million development that delivered the Open University's first large-scale, real-time remote laboratory, and it won numerous awards, about 6, I think. Within his research program at Edinburgh, he leads the Remote Laboratories Group, where he and his team have developed an entirely new infrastructure and approach for operating online remote laboratories, winning yet more international awards and opening up innovative and cost-effective approaches to STEM teaching. So it's my absolute pleasure to welcome Professor Drysdale to the stage and to PCF 11, and come on up. If we could have a round of applause. Thank you.
Good morning, everyone. So, somewhere along here, there should be some slides. Lovely, right. This is the goal that I'm holding today. We want more people having a better education, and if we're being realistic, we're going to have to do that for less money. Now, at first, that seems like an impossible task. There's something called Baumol's disease that means that things like healthcare and education, you can't scale your way to profitability. So we have to do something different. And I come from a country that likes to pride itself on taking a small amount of resource, doing something creative, and impressing the world. Now, I've got some Kiwi crew in the audience here. Hopefully you're on board with that concept as well. But also importantly, in the wider context of the world, we want to design and build locally. The Botswanan president put it beautifully yesterday, saying, we do not want to receive packaged knowledge. And I do not want to send you packaged knowledge. What I'd like to do is show you how there's something that we built that works for us, that I've built in an open way, so that you can tweak and remix and adjust to suit you. And then, hopefully, we can do some cool collaborative stuff with it. But what is it? And how do we end up getting towards it? Well, the background to this, I think, is we find some common ground. We're all dealing with a greater demand for education to be provided to more people on more subjects and in areas that matter to our countries. But there isn't necessarily the money available for that for various internal political, geopolitical, demographic reasons. It's a challenging environment. So to say to somebody in engineering and science, yep, we'd like to educate more people, but we need lots more of this, these huge laboratories, teaching laboratories that we remember from the golden era of practical work in universities, it's just not doable. There are a few universities in the UK who have made humongous practical work buildings, and they're beautiful things, and they do wonderful teaching in them. But they're also very expensive, and it takes a long time to make them. So if you're in a hurry for something, a building isn't necessarily the best way to go. Instead, you can do something a little different, and it gets you an advantage immediately. As you'll know, if you teach someone in person, you have some equipment, and you have some students. And in some cases, You might have a group of people around the equipment, which means that one person does it and uses their elbows and the others sort of get to see what's going on. And you can only do that when the building is open. And for insurance reasons in some countries, that means the building's only open from 8 till 6. So there's a lot of time you're not using the equipment. If you go online, however, all of a sudden, you can access that equipment whenever you like and almost from wherever you like. And in our case, that means I've been able to build remote laboratories that are installed in the foyers of buildings around campus. We don't have a lot of space for creating new laboratories. So instead of creating more of what we have, I've started turning our campus into a science museum. They're in spaces where you can see them. They look like this in some of their forms. Miniature shipping containers. There are 4 experiments per container in most of these. And they sit in public areas where students can walk past, staff can walk past. We take guests there. Visitors can see what's going on. People say, oh, what's that? Meanwhile, students can access them using a web browser. Now, a bit of the magic behind the scenes is how we make this all work with university IT policies. That's not really what I'm talking about today, but if you do have worries about that, I can talk to you until the cows come home about the technology we've put into making this easy to adopt in other institutions. But perhaps the most important thing is not just, oh, it exists and you can connect to it, but it's how we're starting to use it. And we've been using it in our teaching at scale for around about 4 years now, 4 or 5 years of academic years. And we started with people using it at home as you would expect. It was the pandemic when it finally came online. I'd been working on it for a few years before that. And that was kind of the typical use you'd expect. But the instant we were allowed back on campus, we started putting students in classrooms so that they could socially construct knowledge with their peers and with the staff and with the demonstrators. So you have the same social environment that you would have in a traditional lab. And I now have a PhD student who's investigating the similarities between our laptop-based laboratories in a classroom and traditional labs. We probably have about 50-50 usage in groups, in classrooms, and individual usage. And it depends on how many of the experiment we've got. We've got 48 of some, we've got 1 of some others. But the main thing is, in the current era, we know that staff time is one of the big expenses. So in the UK, it's around about £20 an hour to deliver a laboratory to a student if you've got a well set up situation. With the remote laboratories, the core cost of that is less than 10% of that. So now that gives you a great deal of control over your budget for how much human time you add in, and you can add in the right amount of contact at the right times to get the best benefits, and you can also let the students go away and explore. They can play around with the equipment on their own time, finding out edge cases, things that interest them. And we found that when we let students do that, they normally at least match again the time that we've scheduled with them. So we're letting them get more time on target. And that's what I'm getting at with the better education thing, more time interacting with stuff. Speaking of the stuff they're interacting with, come February this year, we'll have over 200 individual experiments live, running on campus, available simultaneously. I don't believe in storing experiments on shelves anymore. If you've made it, connect to it, have it available all the time, and share it with other people when you don't need it. We cover 4 different kinds of engineering: electrical, mechanical, chemical, and civil engineering. The ones on this page for the primarily dry experiments, and we've also developed a couple of wet experiments. These both came from other suppliers that were fully manual, and my team have gone in and turned them into fully online experiments. One of them is a fridge, and the other one is a single tube condenser that heats ethanol and water. quite an impressive amount of power to be controlling remotely, and we give undergraduates the ability to do that. That one does need a little bit of supervision, so I should point out that there's nothing about the experiments that says that they have to be completely run without human attendance. It's a broad spectrum, and when you get into the design of the experiments, you can start trading off which bits you're going to automate and which bits you might have a human do some interaction with. Given that we've got all these experiments, it's not possible to take a naive approach to access and security. One of the approaches that's been used over the years in different locations is simply having a common set of credentials to a very lightly protected piece of equipment, which you share to some class members and say, go onto this shared document and figure out what time you want to access it. And that works fine if you've got about 20 people in a class, because they know each other, and with the best will in the world, they'll probably not run into each other. But the instant you've got 100, 200, or 500 people, as we have in some of our classes, there's just no way that students are going to be able to self-organize, even with the best of intentions. So behind the scenes, I have a booking system that can control access down to the granularity of 1 second, because there are admin tasks that we need to perform on some experiments. And we've got great control over who can access it, when they can access it. We can dovetail things in so that we schedule something here and then let people have free access around it. And it really is helping us deliver those different types of activities with a lot less low-quality time spent by staff on the admin side. So we're using it across first, second, third, fourth, and fifth year. Primarily, we're operating at the earlier years at the moment, where that's one of the problems we've had with scaling. But we've also started to work with universities in Europe, because it turns out that just having a lab is cool, but students can also be part of the education process and co-creation process of designing their own laboratory. And when you start to offer someone the chance of designing their own science experiment, you've got that medical school thing of see one, do one, teach one. This gives them that opportunity to access the teach one phase. And they don't even have to build something to get some value from it. But with the technology we have, there's nothing to stop them going all the way through to a working experiment. A good question might be, what do the students think? And this really surprised me, because in some results that I'm not going to take you through here, together with my team, David Reed, now full-time with me, and I'll explain how our team came together in a bit, we asked the students about the feeling of control they had over the system. And I thought they would say the buttons that make things stop and start gave them a great sense of control. But of course, that's my positionality as the creator, who saw the motor sitting unconnected on a bench and then built a system, and now I can make it work at a distance. The students didn't see that bit. They didn't mind about that. The bit that gave them control was the bit that allowed them to select the data points and put them into a table to complete the task. And it makes perfect sense. That's the bit that they're trying to get done. And they've grown up in a world where, for them in our country, they've had a lot of access to mobile phones and internet, and they've just grown up thinking that you're connected to everything. So their perception is that what we're doing is pretty normal. And they're really comfortable with this being a good way to do practical work. They did point out to us that of the typical things you do in a lab, working with others wasn't something that you could do. But this was because it was the year that was in their bedrooms during the COVID pandemic, and now we're in classrooms working together. So what that really leaves on the list of things that the students think that remote laboratories can't do is the multiple senses piece. And sure, you can't smell a remote lab. And in our case, you can't hear it either, because they're in public places, and I didn't want to be recording the sounds of students walking past the equipment and having private conversations and sending that out. But we do have a plan for it, contact microphones, so sound is a possibility. There are a few subjects where, frankly, the psychomotor skills are important. Chemistry with glassware, for example. But in many, many, many cases, when I sit down and have a conversation with people who are thinking about this, and they say, oh, but you could never do this remotely, it turns out they've bundled their learning intentions together, because that's what we're used to doing. And the process we go through when we co-develop with academics is we unbundle those learning intentions and we break them apart, and then we look at how to bring them back together again. And it's learning how to do that process has made a big difference to our ability to co-develop experiments in this new domain. When we asked them to write down what they were saying or thinking about them in 2020, 2021, the students said some really lovely things about them. So that was great. We thought, yep, this is working well. They also wrote down some really horrible things about my first booking system, because I made them show up to the booking page, and if there were 10 experiments and 250 students, so 20, might have been 20 at that point. Anyway, if one was available, you could book it. But if everyone else was trying to use it, you had to wait and just keep trying. And they really didn't like that. It really wasted a lot of their time. And it was a big effort to write a much better booking system, but we had clear evidence from the students that it was necessary. So I wrote a whole new booking system. That was another 3 months of my life. And then 2022, yep, booking system sorted. Students are happy. The one thing that has gone in the opposite direction is the novelty value. It seemed novel to the students when we first gave it to them. They were third-year students. They'd studied with us for 2 years already. But now, when we hand it even to first years, they just think, yeah, this is normal. I have a mobile phone. I can order a sandwich. I can watch its progress as it goes through the kitchen and comes down the road to my house. So why shouldn't I be able to access my equipment when I'm doing an experiment at this technologically advanced university? So I'm actually not too worried about the novelty being a neutral value at the moment. Everything else is positive. So since then, we've been working on how to complement the delivery in the staff environments with support from the data that's there. And our dashboard work that David's been taking the lead on during his PhD and now is our experimental officer has shown that if you give students a feedback dashboard that tells them the progress they're making on the experiments they're doing, and we have a particular way of doing it. It's out of scope of this morning's talk to explain that. But if you've ever heard of a finite state machine, that's the secret to it. If we show the students what they're doing, it turns out it doubles the task completion rate. So who would have thought giving students feedback when they want it is the kind of feedback they want? And with online systems like this, it doesn't cost staff time to do instant feedback. There isn't a marking period of 3 weeks while you wait for someone to mark the report and send it back, and then the student's not receptive to the feedback. It's, I want some feedback now. I go to the feed dashboard page, there it is. And we can turn that around as well, and we can give staff an overview of where everyone is at in the course, and so they can track how people are getting on with the experiments. And we're working through some of the various policy tensions around doing interventions based on what we see at this point. We're also branching out. We now have a project from a further education charity to develop some wind turbines to help with renewable energy education, and doing an outreach project for secondary schools where we're aiming to help with rural communities that are further afield. Perfect. Excellent. So this is helping. We're working on these ripple tanks, which are really annoying for teachers to set up, so it's a great thing for us to be able to pre-set up and just have available and extend our education to schools that wouldn't necessarily have access to it within the UK. Which raises an interesting question in my mind of just how far can you go with connecting to these. So I thought what I would do when I arrived here is catch up with a friend, an ex-PhD student of mine who's now an academic in Botswana. And we headed up to the north of the country, and in a hotel there on the Wi-Fi, I was able to connect to my experiments and run them. Now, there is a video here, which I think we had working before, but looks like it's not now. So what I'll do is I'll just advance. If you scan that QR code, that'll take you to the YouTube short, and you can see a screenshot or a screen recording of me using my experiments up north on the hotel Wi-Fi. And it's pretty good. It's actually pretty good. There's a slight delay between pushing the button and getting it back. Funnily enough, in the hotel here, if you try it with a link I'll give you later, it's about the same performance in the UK as what I was experiencing in the hotel. It's pretty all right. But this wasn't quite enough for me, so I thought when we went out into the Delta, I'd see what would happen with the mobile phone. Now, we had a great discussion yesterday around the digital poverty aspects of things, or the access to internet, and I thought I'd point out, rather than go through the sort of the numbers of the access, just that when you do have mobile phone access, the quality of that access now, if it's 4G or above, is more than adequate for connecting to a remote laboratory. The download speeds are far in excess of what we need. But what we do need for good quality experiences is for the latency to be low, because it costs you energy to try and remember the thing that you pushed the button for if you have to wait for it to come back. So things are making great progress, but that's something to focus on when you're thinking about provision for remote labs, is latency and quality of service there. But nonetheless, out in the Delta, just to prove we're out there, this was me trying to access the experiments from a moving four-wheel drive truck, and I rather suspect that this one, we've got the magic finger. Okay, the team is saying that one's not working. What I'll show you is a couple of screenshots from that. So I started off just to prove I was out in the outdoors, pan across to my mobile phone, and I was able to connect to my experiment and have a pretty decent go at it. So that filled me with some hope that one of the things that we can do when we're having our discussions around how we deal with access to systems like this is just knowing that a mobile phone signal is enough. A good, this was a 4G signal, worked pretty well. So while we were sitting around the campfire, we're having some discussions around the fishing village that was behind where we were staying, and we were thinking about the children that were there and the hippos and crocodiles that they had to Mokoro Pass to get to area with mobile phone signal, and thinking about whether we could take things to them. And Paul West, who's in the audience, was reminding me yesterday that there's an e-granary project where you put all the internet in a hard drive and take it to people. And that validates some of the ideas that we've been thinking around about packaging up the data we already have and bringing that to places so that you can interact with the stored data as if it's real data. You could do the same thing with simulations, but with the rise of AI, it worries me that there'll be a lot of vibe-coded simulations out there. And as someone who used to do a lot of simulation work, it's very easy to get results that look plausible but are just not right for various numerical reasons. So as we get into a world where the barrier to creating a simulation is lower and lower, we're going to have to put more effort into validating those. And that's one of the reasons that I think real experiments are incredibly important, because science developed by do a measurement. If it doesn't make sense, upgrade your thinking. Whereas with simulations, you have to question whether the simulation is correct. There's an example of another Northern Hemisphere development, a similar open system, this one for mathematics assessment. A colleague and friend of mine, Chris Sangwin, who's now at Edinburgh, has built this online maths assessment system. It now has a life of its own in Africa. The third African Stat Conference ran last month, and that was in conjunction with IDEM's Maceno and Caltech. So Chris didn't force that on anybody. He didn't go and organize it. That's something that he's been supporting, but it's been growing separately. So I think it's a really great example of a technology that's been useful, and there's been pull for that as well as push. So turns out we've got a Commonwealth, and we've already managed to connect to some experiments across a great distance within that Commonwealth. It strikes me that if we develop experiments in different countries that suit what those countries need, there's a really good chance that the diversity of experiments and contexts there will help enrich what we all do, particularly if we can share them. Then we get some capacity benefits and also some resilience. However, it's quite challenging developing a new technology when you face old regulatory systems and old regulations that think of a very particular way of doing teaching. So in order to see this grow some more, I have some comments on what we might need to change. But to look at what we might need to change in future, I think it's helpful to look at what has changed in the past. So I'm going to take you back to ancient British universities. And in 1824 in Britain, and in Scotland in particular, there's a reason why I've chosen this particular year, the way that academics ran their lives was they put on a course. In Scotland, they charged students a fee at the door. Anyone could come. And the academic put that money in their trouser pocket and presented the lecture. So there was zero incentive to produce a laboratory because you'd have to pay for it out of your own pocket. And at that time in Edinburgh, the leading chemistry academic across pretty much Europe, I mean, there's always a bit of fighting for first and second, was brilliant at these lecture demonstrations. And I did the numbers, and I think they were taking home the best part of about £750,000 British pounds a year in today's money. So they had a really good reason to argue that moving to practical lab-based classrooms was a bad idea because it would mean the end of their era. And there were people who wanted it. There were students who wanted it. There was student feedback saying, we want to learn practical chemistry. But the University of Edinburgh, in its infinite wisdom, said, no, we don't want that. And instead, in 1824 in Germany, Gießen University said, all right, we hear you. They bought a building. They paid for 2 lab assistants and a whole lot of equipment, hired an academic and said, put on a practical chemistry course. And they put on about 10 times the hours for about 2.5 times the cost. So for a little bit more money, you could get an order of magnitude more time and better quality time because you could get hands-on with the stuff. So unsurprisingly, there was an exodus of students from Scotland to Germany to study chemistry. And what happened there was that the way that money and time were allocated changed. The way space was allocated changed. And that's what opened up the era of practical work that we have today, that we take for granted as being the standard way to do higher education. But it's only 200 years old. And funnily enough, I think things are changing again because we've got AI. Now, AI has a wonderful hype cycle where we think it can do many things. It also has some issues. And I'm sure we're going to hear more from other speakers on some of those issues. But for now, the main thing that it's telling me is that measuring outputs is no longer enough. We have to look at behaviors as well. So if we're going to start assessing behaviors, then I think it's time to change practical work again. And what I mean by that is we're going to need to adopt more of what we're doing with remote laboratories and others who do remote laboratories around the world. But in particular, start looking at what we can do with that data to try and understand what students are doing so we can give them feedback on what they're learning, they can get feedback themselves, and develop people with the skills and actually directly figure out what those skills are and what they look like and how varied they are, and start developing the skills directly rather than using a report as a proxy for the development of the skills. And to do that, I think we're going to have to reallocate money, time, and space more broadly. We've had to do it at Edinburgh. We've had to do money and time differently. And that's been a long conversation. So I thought I'd explain a little bit about that conversation. Basically, the traditional Northern Hemisphere higher education situation is a single academic is given a single course code and told to go and teach it. And you get given some standard university tech platform, and away you go. If you want to do a remote laboratory so you can do some really interesting stuff without a lab, you don't have a hope because the technical barrier to building the tech tool is so high that you can't do it in the discretionary time that you have for developing a cool feature on your module, because it's just one of the things you have to do. And that means you need a team of people, or you need a lot of time allocated to get over that tech barrier. And once you do, you realize the tech you're developing is embedded in a teaching context, and there's an interaction between the things you're building in that teaching context. So you can't just outsource the tech without it then dominating your teaching context. And we're already seeing the supply of software from one country to another influencing or exacerbating cultural differences between those countries. So for us, because we're developing in our context, we can co-develop with academics the user interfaces, the experiments, and to a certain extent, the software behind the scenes, in particular the way the bookings are done. And what that means is that instead of having this traditional thing where we say, you're an individual craftsperson as an academic, and if we want to improve teaching practice, all we need to do is fund a little bit of coffee and a couple of biscuits, and we'll put you in a room together, and you can talk about how your chalk technique needs to change. That era is over. And the idea of splitting academics and professional services, and never the twain shall meet, I believe, is over. Instead, we need multifunctional teaching teams, and we need a blend of our academic and services. And this has a name. This is a concept that's been around for a while now, the idea of a third space professional that blends those two things. And there's an excellent paper here from Celia that describes more about what that concept is. So we're living that in what we're doing at Edinburgh at the moment. And we had to start by asking for forgiveness rather than permission. And that's a really difficult thing to do when you're junior. Fortunately, you heard from my title that I was hired at the University of Edinburgh to do technology-enhanced science education. That was an initiative from the principal, Tim O'Shea, some years earlier that led to that position being available. And I pitched that I would do remote labs to help Edinburgh with its lab space problem. So I had a mandate coming in to do this. But if I'd been a junior lecturer, I don't think I would have had the permission space to even do that. But for all that, I still had to start it in my house. So during the pandemic, my living room turned into the construction of the first 4 wooden boxes of our Generation 1 design. It turned out we had a workshop that had a couple of workshop technicians that weren't busy because the students weren't there. They were great at doing manufacture, and so we turned a student workshop into a wooden box manufacturing environment, and we built 50 of these experiments, which I then ended up hosting in my living room for a little while before we then moved them back onto the campus. And that was a really interesting challenge in itself, because I was trying to convince people that this big pile of wooden boxes was a good thing to have in a space. But we got there eventually. We got them up and running. And I thought what I'd show you is just how long it takes to get something accepted in an environment. So this is a bit of a map of what happened. So I started in 2018 and just went, right, I'm getting on with it, and I started writing code. In 2020, I convinced a couple of technicians to help me, and I got some, approval-ish to do this. They weren't busy otherwise, so we were using resource, everyone was happy, and I had a PhD student that was funded to work on this. And so that core team of 4 of us worked really hard to get the first experiments up and running. And it worked out really well, because at the end of, or the middle of 2022, I was able to promote one of them into a position where they're 50% working on remote labs, the other one got promoted in the other one's job, and the PhD student, in complete stroke of good fortune, I got another permanent post from the university to have a full-time experimental officer. So I then also got some buyout to work on this officially as well for 40% of my time. So it took a bunch of just doing it anyway. I mean, like, we were delivering to courses in 2021, 2022, before this all became formal. So it's been a really interesting process of just holding the space open. And we've put a lot of staff time into building the system. It's open. And one of the reasons I want to share it is so that You can concentrate on building the experiments you want to build, not having to do all the infrastructure. Oh yeah, I should say, I've had 4 different heads of school as well, and they have a lot of power, so there's a lot of reconvincing people that you need to do what you're doing. So the team as we have it now has an electronics person who's 50% of the time, a hardware person who's 50% of the time. That's a little bit lower at the moment. Someone who's full-time working with the teachers and doing the user interfaces and co-developing the teaching tasks and the remote lab tasks. And frankly, at the moment, we pretty much duplicate traditional lab work. We would very much like to start doing things that you can't do in a standard lab, but because duplicating standard lab work is what is paying our bills, that's where we're at the moment. And it's a really, really good team. We really enjoy the way that we meet. It is not hierarchical at all. I make lots of mistakes or get lots of things wrong, and the team know lots of things about the different subjects we're doing, and there's none of this sort of super hierarchical stuff in the way we work. And it is great fun. Really satisfying to see how good the team are. And beyond the team, we have the huge number of people that are involved in the teaching administration across the course, the teachers themselves, who have all come on board with what we're doing. You know, we've had to understand the different ways in which we're working. This is just some of them. So what I started as a tech project rapidly turned into a people project. And that has been absolutely fascinating for me. Life just got more interesting. And obviously, many conversations with Anne-Marie along the way prepared me for some of the interesting people side of this. The place we're in now is we're working to figure out what we need to provide to give people a platform or a footstep to stand on that helps them get over that activation energy that we faced. So one of them is a portal that we would supply pre-configured so that all you have to do is make the interesting experiment bit, and then that portal will take care of connecting to our servers, and you just have to focus on the experiment and not worry about how the remote lab works. So that means that you could focus on building up the competence and understanding of how to use remote laboratories by trying experiments. And there's delaying the need to be able to do the Linux administration, the server development, or the server operation stuff until such time as that makes sense for you to run. So I was just thinking ahead to, in an ideal world, one way that you might consider doing something is saying, well, tell you what, we'd really like some labs in a country. So I've just randomly picked the one that we're in, hint, hint. But the idea being, hey, build some experiments, put them somewhere, and then realize you can access them in multiple locations and start taking advantage of this. You know, they don't have to go in foyers. You could just put them in a building somewhere, but the fact they can go in foyers does make them really efficient for space. Add other sites for resilience. And then I've had a look at where the cloud data centers are. It looks like Johannesburg has Amazon and Google. I've used both in the past. I'm currently using Google for our production servers. So if you wanted to reduce the sort of the triangle of latency between user and server and experiment, then you could move the relays that you're using to a local data center. And you could do that in any of the countries that you're in. You could choose to do that. But the performance here is so good that you wouldn't have to do that initially. I was trying it at my hotel room this morning going, nope, that's good, that's fine. So there really is, I think here, a graduated way to get started with this, which I hope will reduce the barriers. But I'm super keen to have conversations with you about the challenges that you have, the opportunities that you see, so that I can understand better how we might collaborate. So to bring this to a close, 1824, the idea that you would add lab space was really novel. And I mean, Edinburgh carried on fighting that concept for a good 15 or 20 years after Germany built their first lab for students. So I don't underestimate the difficulty of change. Now I contend that adding third space is novel, giving your people the space to do that teaching and tech with an explicit understanding that some of the tech build is going to take much more time than you would normally allocate for an academic to a particular course, so you need to split that out into a team and have them work across multiple courses. Those barriers include career recognition and research-focused universities, but also just the challenges of a system where you assign people a thing to get done on a course. Now we have to understand how that works when it's more distributed. And for younger people, it's much, much more important to follow the KPIs that get them promoted. It makes sense. So I think we need to change some of those as well. Recent views on the matter are that this concept of third space hasn't really influenced policy and practice at an institutional national level. I've managed to influence at the level of my organizational unit, and I'd really like to see that change extend further, because I think it builds us the tools that we need as a sector to do the stuff that we want to do, and to do it with the money that we have. So, if you'd like to give some labs a go yourself, that QR code there will take you to a link. You don't need an account. You simply will go straight to a page where you can scroll through. There's probably something like 70 or 80 experiments that are available there of 3 different types. It'll take you to a user interface once you've booked a session. Give it a go. Try it out. See what the latency is like. See what the experience is like. That link's going to be open for an indeterminate amount of time. So it's intended to last for the next week or two. And should you end up wanting to do some demonstrations where you're actually organizing someone to be there so you can show it to them, just let me know in advance and we can set you up with a link that will definitely be working on that day. So at some point this open link will close. So with that, I invite you to have a play with that, and please, explicitly, every one of you, I welcome you to get in touch with me to find out more about what we're doing and see if there's a collaborative opportunity. Thank you very much.